وعليكم السلام ورحمة الله وبركاته.
بسم الله الرحمن الرحيم. الحمد لله والصلاة والسلام على رسول الله. Let's continue the discussion. هذا نيو channel، ايش المشكلة؟ الو
في شباب الظاهر بعد الميتنج الاول.
ايش هذا مختلف عن الاول يعني؟
هي في اثنين، اللغة واحد.
اي واحد يقول له
خلاص يا دكتور، دام انت الاورجنايزر فامورك تمام ان شاء الله.
بس مو هذا اللي نستخدمه كل يوم، مش اللي ليش واحد اللغة يعني؟
اعتقد في احد بس يمكن سوى البث قبل ما تسوي انت.
اوه اوكي.
حصل.
Alright, طيب بسم الله الرحمن الرحيم. الحمد لله. I have now 60 students, so good. Okay, let's start. Then let's start the discussion. Bismillah ar-Rahman ar-Rahim. Yes, the last thing I was talking about chapter 9 and the bonding, and we'll continue the discussion about the bonding. Now, yes. Now we know the structure. What was the name of the theory that we used before? To find the shape of the molecule, what's the theory name?
Valence shell, electron pairs.
Yes, valence shell, electron pair, repulsion theory or model. You have to know this, and you have to know the name very well. Valence shell electron pair repulsion model, which we discuss it here. And I'm not going to discuss it again. I hope you know how to do it, and you know how to find the shape of the molecule and the angles. Then we talked about polarity, and I told you that this is U, which is dipole moment. And I told you which molecules will cancel each other, and the dipole moment, when is it going to cancel and when is it going not to cancel. Like here, for example, each bond is polar, but the whole molecule is polar. So each bond here is polar, and there is a force, dipole moment. But this force and this force will cancel each other, and then it will be zero. And that's why each bond, this bond is polar, this bond is polar, but the whole molecule is non-polar. You have to know this. Also here is each bond is what? Each bond is what?
Polar.
Polar. But the whole molecule is
non-polar.
It's non-polar. Why? Because they cancel each other. They cancel each other. Which are the molecules that we're going to see that they cancel each other? If you have AB2, E0, AB3, E0, AB4, E0, AB5, E0, AB6, E0, and then we have AB2, E3, and AB3, AB4, E2. These molecules are actually nonpolar if the terminal atom is the same. Atom is the same. The rest, the other things that we discussed last time and the shapes that we did last time is polar. But these are non-polar, but the terminal atom must be different from each other. Okay, we also, for example, this one, this is water now. What's the general shape for it? It's AB what?
2.
AB2,
E1.
E2.
E2. Each one is 2 electrons. Each 2 electrons is 1 E. So is this polar or non-polar?
Not polar.
No, it is polar. Look at the shape here. That's the electron domain shape. Is it among these? These electron domain are non-polar. This electron domain is non-polar. AB2, which we just wrote a while ago, E2, is it polar or non-polar? This is AB2, E2, AB2, E2. Is it among these? Is it among these?
No.
No.
So, okay. All right. So it is actually polar molecule. Good. Right. Good. This compound, is it polar or non-polar? Again, what's this? The electron domain. AB4, E0. All right. AB4, E0.
Not polar.
Is it polar or non-polar?
Number.
Non-polar.
Non-polar. Very good. Now, this one is also AB4, E0. Is it polar or non-polar?
Polar.
Why?
Because of
Non-polar.
not terminal.
Because terminal atoms are not the same. So yes, it is polar because this terminal atom is different. The white is different from the green atoms. So this is terminal atom, not the same. That's why it is polar. Very good. This molecule, is it polar or non-polar? The one at the top.
It's non-polar.
Why non-polar? Because this force cancels this force, and this force cancels this force, and that's why it's non-polar. How about the one at the bottom?
It is polar
Polar. Why?
because they didn't cancel each other.
They don't cancel each other. Very good. Done with this. Now we want to know about how the bond take place. All right. The bond take place by the interaction of the orbitals. So the orbitals interact with each other to make the bond. Like this is a hydrogen. This is the 1s orbital of the hydrogen. Interact with the 1s orbital of the hydrogen to make this bond. This is how the bond take place. Interaction between the orbitals to make the bond. This interaction can be between S and S, or P and P, or S and P, or all of this can interact with each other to make the bond. Look how the bond takes place here, how the bond takes place here, how the bond takes place here. When the bond is, we call it here, head to head, then we call this bond, or they call it head to head, or end to end. Sometimes some people call it end to end or head to head. Then we call this bond sigma. You have to memorize the name. Sigma. Sigma. All right. What's the name? Sigma. Okay. Why I'm saying this? Look at this one here. Look at the orbital here. Between this one and this one. What type of bond is this one? It's P with P. What type of interaction is this? Also head to head. I'll repeat it one more time. P with P. All right. And what type of bond is this one? Also sigma. Sigma. All right. Sigma bond, P to P, and it is end to end. Don't forget this name, end to end, or what's the other name?
Head to head.
Head to head. And what do we call this type of bond? Sigma. Don't forget this. Same thing here. The hydrogen is interacting with the F. What type of bond is this one?
Sigma.
Why?
Because it's head to head.
Head to head or?
End to end.
What's the other name? End to end. End to end or head to head. Very good. Now, when this head-to-head comes to place, we look at the energy. As they are far from each other, they are at zero energy. As the elements get closer and closer and closer, there is some interaction between the electrons and the nucleus, and as a result, the energy of the whole two atoms together become low, until they come to this point where the distance is 74 picometer. This is the maximum interaction. If you make the atoms even closer to each other, the energy will start to go up. Why? Because of the repulsion. Here there is interaction between what and what? Between the nucleus and the electrons from the other metal. The other element. Here, why the energy goes down? Because this nucleus starts to attract the electrons from the other atom. This nucleus here, it does not interact with this electron because they are far away. But if they get closer, then this electron, which is here from the other atom, this electron from the other atom, become very close to the nucleus and start interaction. This interaction causes the energy to go down. But if you get it very close, even closer than 74, the best time is when you have it at 74 picometer for hydrogen. But if it get it closer than 74, there will be repulsion between the nucleus and this nucleus. They will become each close to each other. There will be now repulsion between the nucleus. Is this clear? So the best thing is at this distance where we have the bond. If you have it even more, there will be repulsion. Now, when the hydrogen interact with sulfur, we're going to have the hydrogen come closer to here and closer to here, and it will make this bond. All right, and so this is the hydrogen, this is the electronic structure of what? Of sulfur. This is the valence of sulfur. When the hydrogen come here, this room will be occupied with the electron. The red electrons are from where now?
From the hydrogen.
From the hydrogen, and we'll have the interaction like this. So what should we expect the angle between hydrogen, sulfur, and hydrogen?
90.
90. Why? Because the p orbital are what? The p orbital are what?
Head to head with those orbital.
No, the p orbitals, this is the px or py, and this is px. They are perpendicular to each other. When the hydrogen comes here and interact with it, the angle here should be what? 90. Is this clear?
Yes, yes.
Yes. This is, and we found the angle to be 92 degree, which is acceptable. All right, this is the theory that we're using here is called valence bond theory. Valence bond theory. So what's the valence bond theory says? That orbitals will interact with each other and when the interaction is head to head, or end to end, same word, some people use this one, some people use end to end, then we call this bond sigma. We call this bond sigma. Is this clear? That is valence bond theory. Good. Now, if we have Se H2, how the bond is going to take place? Again, don't forget that Se has a structure which is argon and then 4s2, 3d10, 4p4. What's the valence electrons?
4p4.
What's the valence electron? No. What's valence?
6.
Yes. Last what? What's valence? What's the meaning of valence?
Last S and P electrons.
S and P orbitals. Okay. Then we have 4s2, 4p4. What's the total?
6 electrons.
6. All right. And if I want to draw it, actually, this is 4s and this is 4p. P. This is the now when the hydrogen come, where is the hydrogen going to interact? We have these two rooms empty, this room and this room, which is, as I said, one like this, the other one is perpendicular to it. And then this is Py and this is Px, the orbital Px, where the hydrogen are going to interact. One hydrogen will come here and the other hydrogen will come here. And then I will draw a small electron for hydrogen. I will make it small, as if this is the electron from hydrogen, this is the electron from the other hydrogen. And what's the angle between the p orbitals? If we have two p orbitals like this and like
90
this,
degrees.
what's the angle between them? 90. All right. And as a result, what do you expect the angle in H2S molecule? I mean SeIH2.
90.
And it was found to be 92. Is this clear? Very good. Now, when the interaction is like this, this is a p orbital with a p orbital. Then what type of interaction is this?
Head to head.
Head to head.
Head to head, which is called sigma.
Sigma.
Head to head. Or what's the other name?
And
End to end.
The other name is end to end. But if the interaction is like this, the p orbital is interacting with the p orbital by, there is interaction between them. I can make them, when they interact with each other, there will be, you can imagine it like this, and the other p orbital like this. Then what type of interaction? This is not end to end. This is called side to side. Or what's the other name? Face to face. And this bond, we call it bi. You have to be careful with these names. Let me try to redraw this. Okay. So if we have it like this, so the p orbital is interacting with the p orbital, but this time they are interacting what? Side to side or face to face. What do we call it? Bi. You have to know this this type of interaction. Is this clear? Any question? Any question? So we have two important bonds. The first one is called sigma. The other one is called bi. What is sigma?
End to end.
End to end or head to head? End to end or head to head. What's the other name for this one? Pi. Pi bond. This is pi and this is sigma. What's the pi bond?
Side to side.
Side to side. Or what the other name?
Face to face.
Very good. I want you to write this. Very good. Now, there is another theory also. What was the name of this theory that we just talked about a while ago?
valence bond theory.
Must memorize the name. Valence bond theory, valence bond theory. And what do you mean by valence bond theory? As I said, the orbitals are interacting like what we did here. Valence bond theory, valence bond theory. Now, we're going to another theory, which is called, also related to, but it's actually hybridization of atomic orbitals. Hybridization of atomic orbitals. This is the second theory, which is related to, it's part of valence bond theory, but we're going to talk about specific things. The word is hybridization. Write the name and memorize it. Hybridization. What's the meaning of hybridization? English now. What's the meaning of hybridization?
تهجين.
Yes. But in English, what's the meaning of تهجين؟ ايش معنى التهجين؟ ترى hybridization اسهل عندي من التهجين. ايش معنى التهجين؟ يا شباب.
تجميع فيتشرز من
تجميع. اوكي، الحقيقه انا ما اعرف ايش معنى التهجين، انا اعرف ايش معنى هايبريديزيشن بالانجليزي، بس تهجين والله ما اعرف ايش معناته. ولكن in English hybridization means ايش قلت انت؟ تجميع، صح؟
ايوه.
which is what is it?
Mixing.
Mixing. This is the meaning of hybridization. I'll take تهجين away and I'll put mixing. Hybridization is mixing. Okay. The other theory is called hybridization. Hybridization. All right. Let me give you this hybridization theory, which is part of atomic orbital theory. But now, what I'm going to do, I'll take. Let me see. Put it here. I'll do it from now. Or, let's go over the slide. Better. Okay. Let's go over the slide. This thing. Don't forget, what's the word that I want you to memorize?
Hybridization.
Of what? S and P orbital. S and P orbital. Hybridization of S and P orbital. Okay? What's this theory? It says that we know that in one S and the S, not one, in S, we have one orbital. And in P, we have how many orbitals?
3 orbitals.
3 orbitals. And do you remember the shape, which is, what's this? A, B, N, I'll call it E, M. What do you call this structure that I wrote here?
Electron domain.
Electron domain. That's what the word I want. Electron domain. Okay. And we know electron domain, we did it before many times. Now, depending on N plus M, which is going to be what? 2 or 3 or 4 or 5 or 6. What's this? N and M? The total. When we write the electron domain, we are going to have N plus M. 2, 3, 4, 5, and 6. This theory, which is called what?
Hybridization.
Hybridization of S and P orbital, says the following. Listen carefully now. When these orbitals interact with each other, or when we make the bond, there will be hybridization of the orbital before the bond. If we have the total N plus M equal to 2, then 1s would mix with 1p to make what's called 2sp orbital, 2sp orbitals. Okay, when we have the total n plus m equal to 3, then the theory says that 1s will interact with what? 2p to make 3 orbitals. To make 3 orbitals, each one is called now sp2. Clear? The theory says also, if we have 4, then what will happen? 1s will interact with what?
3p.
3b.
Make what? 4 sp3 orbital. When we have 5, then what will happen? 1s will interact with what? How many p?
4p.
We cannot have 4p. The maximum p is what?
3.
3. So how many are going to mix? Only 3. But we need one more. Plus
One more S.
No, 1p orbital. To make how many now? 5. Each one is called sp3. sp3
P1.
d1. You don't have to write d1, but or if you don't write it, it's okay. When we have 6, then what will happen? 1s interact with that.
P. 3P.
3p, and then
2D.
2d to make 6. What are the name of these orbitals?
S.
P3,
P,
P2.
P. That's the theory. That's the theory of hybridization. The theory of hybridization says, before the interaction, look at the electron domain and find the electron domain, A, B, N, E, M, and then calculate N plus M. If it is 2, then there will be mixing of 1s with 1p to make 2 sp1 orbital. If it is 3, then 1s will interact with 2p to make 3 sp orbitals, sp2 orbital. And then if it's 4, 1s will mix with what? 3p orbital to make sp3 orbital. And then if we have 5, then what type of mixing? 1s will mix with 3p to make 1d to make 5 sp3 d1 orbital. And then if we have 6, we have this mixing. I hope this is clear. That's why, let's have some example. Using the interaction, using this theory, which is hybridization, if we have this molecule, then what is the hybridization that we're going to have? What's the electron domain?
AB3 E0.
E0. What's the total? This one plus this one.
3.
3. Then what hybridization we're going to have?
SP2.
sp2.
3sp2.
sp2, as simple as that. How about this one?
Doctor,
What's the electron domain?
Doctor,
Yes.
how can we calculate the electrodomain?
Oh, this last lecture we have it. Did you attend last lecture?
Yeah.
I cannot go back. It's a long process. We have to B represent the bonds, which is single bond or double bond or triple bond. And the E, this is B. And then E is actually the electrons, which is like this. And we will have some examples in a while. That's how you make it. This is AB2, E0. Then what hybridization we're going to have in this molecule? SP what?
SP1.
SP.
Some people write the one and some people don't write the one. If you write it SP, that's enough. All right. But if you write SP1 is okay. It's usually okay, but not always. Okay, good. How about if I have S, yes, S, what's the electron domain for this molecule now?
AB2.
2,
E1.
1. What's the hybridization?
3.
So 3
3 SP2.
Oh, we're going to make sp2 hybridization. There will be 3 orbitals of sp2, exactly. 3 orbitals of sp2. Is this clear? And let's continue. How about if I have P, F, then what's the electron domain? Quickly.
A, B, 5, E0.
E0, what's the hybridization?
5, SP3, D1.
5, I care about the hybridization.
Okay, SP3, D1.
3, D1. And again, the one, some people don't write it, so I'm going to take it away to tell you that you can write it. It's okay to write it or not to write it, but usually people don't write it. It's like this. Is this clear? So this is the theory. It says that orbitals will mix. You have to memorize. Don't forget this. I need you to memorize this very, very well, because we're going to solve now the structure using this memorization. Don't forget this one. Always count the molecule and then find the hybridization. Now, let's look at this molecule. We have this molecule now, B, F, and F. All right? And now, what's the electron domain? BeF2. So BeF2. What's the hybridization?
AB2, E0.
This is what's the electron domain? AB2E0. So what's the hybridization that we're going to mix?
SP2.
SP. No, not SP2, SP. Look here, what happened? This is the S of PE, and this is the 2P. One orbital of the S, this orbital of S, will mix with one P orbital, and we're going to make new 2 orbitals. Each one is called SP, SP, and SP. And the other one will be empty. See, this one and this one are still 2P and 2P, and they are empty. Then the electron from hydrogen will come and mix here and mix here to make the bond. This is the shape of the S orbital. This is the shape of P orbital. When they mix, they're going to make 2 new orbitals. Each one is called SP and SP. Then the hydrogen will come. One hydrogen will interact with this SP. The other hydrogen will interact with this SP. So the red thing is the S. This is the hydrogen atom, and this is the hydrogen atom. Is this clear? I hope this is clear. Now, when we have, that's what will happen. Whether it's hydrogen. See, now this is same orbital. What is the name of the P, this P orbital? This green orbital, sp. What's the name of this orbital? sp. But what's the name of this white orbital?
It's also B.
P only. And
Yeah,
this orbital,
B.
P. Because as I said, two will interact to make these new two orbitals, and the other will have empty orbitals. Good. Let's look at BF3. What's the electron domain?
AB2, AB3, 0.
What's the total?
SP2.
sp2. What will have a mix? The total is 3. So what's the hybridization?
SP2.
sp2. sp2. This means 1s will interact with how many? 2p orbital to make sp2. 2p orbital to make sp2. And that's why they will mix to make sp2 orbital. And 1p orbital, which is this one, will stay empty. And that's how they mix. And then we have 3 sp2 orbital, sp2, 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 and then the hydrogen or the fluorine will come interact with the other elements like this. Again, this is the p orbital before, this is the s, and this is the 2p, and this is the 2p. They will mix together to make these new 3p orbitals. What's the name of this orbital? What's the name of this new orbital?
sp2.
And this orbital?
sp2.
3 new orbitals, each one is called sp2. And what will happen to this p orbital? It will stay as it is. See,
Same.
white thing is the p orbital, which is this orbital, which is empty. Is this clear? That's what the theory says. Good. And then they will interact with the fluorine like this. Okay. What type of bond if we have it head to head?
Sigma.
It's all sigma, sigma, and sigma. Don't forget this. Very good. Now, when we have CH4, all right, then what's the electron domain?
AB4,
A, B,
B0,
E, 0. What's the total? N plus M. 4. What's the hybridization?
SP3D,
3. No, sp3 only. sp3. So what are you going to mix?
1S and 3B.
Exactly. That S1s with 3p orbitals. So we're going to mix all these together. And what are we going to make? New 4 orbitals. What's the name of each orbital?
SP3.
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 sp3. Then what will happen to the hydrogen? Will come and interact with like this. Let's have it in drawing. This is the 2s of carbon. This is the 2p of carbon. When they mix together, we're going to make how many new p orbitals?
4.
4 new orbitals. What's the name of this orbital?
SP3.
Each one is called what?
sp3.
This one is called? This one is called?
sp3.
Okay. How many p orbitals are left?
0.
0, nothing.
Zero.
So we
Yes.
don't have any empty p orbital. Is this clear? Good.
Yes.
Then the hydrogen will come and make the bond. What type of bond is this?
End to end.
So it is what?
Pi. Sigma, sorry.
Not
Sigma.
pi. All of them is sigma, sigma, sigma and sigma. 4 sigma bonds. Good. Let's go further. Let's go to PCl5. P, Cl, 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 and Cl. What's the electron domain?
AB5.
zero.
AB5.
A0.
0. What's the total?
5.
What type of mixing we're going to make?
SP3D.
sp3d. Why we don't go to sp4?
Because it's only 5.
In P only we have 3.
In P we have only 3 orbitals. And that's why we're going to mix S with 3p and 1d. Only this one. We'll take 1 only. And what are we going to make? How many orbitals? New orbitals.
5.
Each one is called what?
SP3D.
sp3d, which is 1 plus 3, 4 plus 1, 5. And these are 1, 2, 3, 4, 5. And then how many d orbitals we're going to have empty?
4.
4. Why? Because we took 1 away. Is this clear? Okay, let's see them now. Let's see them in shape. So this is the p orbital, and what's the name of this orbital?
SP3D.
sp3d. And what's the name of this orbital?
It's the same. SP3D.
This orbital. How about this orbital?
Same.
And how about this orbital? 5 orbitals. All of them is called sp3d1, or as I said, usually we don't write the 1 like this. So we keep it sp3d. Then the chlorine will come and interact. What type of interaction?
Sigma.
Sigma. How about this interaction?
Sigma also.
How about this interaction?
Sigma.
And how about this interaction?
Sigma.
And also the one we did. So we have 5 sigma bond. 1, 2, 3, 4, and 5. Good. And last question is, if we have the SF6. What's the electron domain?
AP6E0.
AB6E0. What's the total?
6.
Total is 6. What hybridization I'm going to make?
SP3D2.
sp3d2. What I'm going to take? I will take 1s, 3p orbitals, and how many d? 2 d orbital. So what's the total?
5. 6.
6. Count them. 1, 2, 3, 4, 5, 6. What am I going to make? New 6 orbitals. What's the name of these 6 orbitals?
SP3D2.
Each one is called sp3d2. How many d orbital will be left not used?
3.
3.
3 d orbital will be left not used, and then the fluorine will come and make the bond like this, like this, like this, like this. So the red ones is the electron from fluorine to make the bond like this. And this is the shape. Now, what's the name of each of these orbitals?
sp3d2.
sp3d2 each one. And then the fluorine will come and interact. What type of interaction? It's very easy.
Sigma.
Sigma. 1, 2, 3, 4, 5, 6. All of them is sigma. Very good. So this is the, as we said, when we have sp, then they will be like this and they will be linear. When we have sp2, they will be like this and it will be trigonal planar. If it's sp3, it will be tetrahedral. If it's sp3 d, then it will be trigonal bipyramid. The sp3d2, we have octahedral. Did we see these names before?
Yes, that's picture.
That's the orbital, the names that we use for electron domain. Remember electron domain? I hope it is clear, and we took this before, and this is clear. Now, go to example of, let's have an example. NH3, what is the electron domain for NH3?
AB3 E1.
AB3 E1. So what's the total? The total is 4. What type of interaction, hybridization we're going to have?
sp3.
sp3, exactly. So what are you going to mix?
S and B.
S and how many P's you need to mix with it?
3.
2.
No, not 2. You have to mix what? 3. You make hybridization. How many orbitals you're going to have total?
4.
4 of them. 1, 2, 3, and 4. And now, how many electrons do we have here? Where are we going to put the electrons? These electrons that you're looking at here is from the nitrogen only. They are mixed together to make sp3. And why I have 2 electrons in here?
شو اسمه أول شيء أوزعها على فوق بعدين أضيف واحد.
Are these 2 electrons?
Yes, 2 electrons. No, لا ما هي هذه.
This is the electron pair. All right, but these orbitals have only one electron in it. When the hydrogen come, what will happen? I will put now the electron from hydrogen as small, even though it's not small, but just to show you that these small electrons, they are the same size, but I am making them different to tell you that the small electrons are coming from where?
From hydrogen.
From hydrogen. But this one is these 2 electrons are coming from where?
Nitrogen.
Which is what? The electron pair. That's exactly how you make this one. Now, let's go to another example. Let's go now to C double bond C H H H H. So I'll call this one carbon 1 and I'll call this one carbon 2. What's the electron domain of carbon 1?
AB3 E0.
AB3 E0 and carbon 2.
Same. AB3 E0.
AB3 E0. So what hybridization we're going to have for the carbon?
SB2.
sp2. How about the carbon 2?
The same. SB2.
Exactly. And so we're going to mix here. We're going to make one S with, so this one is sp2, this one is sp2. We're going to mix one X with 2p. And we're going to have one p orbital extra. Now we're going to make, this is sp2, sp2, sp2 from here, and the p orbital will be empty. But when we distribute the electrons, we're going to have 3 electrons in here in the sp and 1 electron in the p orbital. The p orbital will be left as it is. Now, when we have this structure, we're going to have this one. This is sp2. You remember the sp2 will interact with each other. What type of bond between this one and this one?
Sigma.
Sigma. What type of bond between the sp2 and the hydrogen?
Sigma.
And this is hydrogen and carbon.
Sigma.
This hydrogen and carbon. Sigma.
Sigma also.
Hydrogen and carbon. Also sigma. But look at this P with this P. They will interact with each other to make this bond. What type of bond is this one now called?
Pi.
Pi. Why do we call it pi?
Entropy.
What?
Side to side.
Side to side or face to face. Side to side or face to face. And that's why this is called pi. And this is, by the way, one bond. It's not two bonds because they're interacting like this. But this is one bond, one pi bond only. Is this clear? Now, I will give you a rule. Whenever you see any bond like this, when it is one bond, the first bond is always what? Sigma. But the second bond is going to be what?
Pi.
It's two
Sigma
bonds.
and pi.
One of them is sigma, the other one is called pi. How about if we have 3 bonds?
1 sigma, 2 pi's.
When we have 3 bonds, then 1 sigma and 2 pi bonds. Very good. That's general in anything. Good. Let's look at this one. I want you to tell me how many sigma bonds do we have in here? Or before sigma, let's have how many pi bonds, easier to count.
4.
One of them. 1, 2,
7, sorry.
3, 4, 5, 6, and 7. Exactly. So we have 7 pi bond. How many sigma? Quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9,
14.
10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, according to what I got. Calculate. Who got the same answer? Try to calculate it yourself. I got 21, but I don't know if it's 21 or not. I'm not sure 100%. How many sigma? Did you get it?
Yes, 21.
You got it. Let's hope so. Really don't know. It says here, oh, yeah, it's actually asking how many carbon-carbon sigma bond. Only carbon-carbon, not carbon N. So I'll count how many carbon-carbon sigma bond. This is carbon. Anything that is not written as actually carbon. So this one between carbon and carbon. So this is 1, 2, 3, 4. But this one between carbon and N, so we're not going to count. This one carbon and N, this one carbon and oxygen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So exactly, carbon sigma bond is 12. And total sigma bond is 21. I hope this is also clear. Good? Okay. Okay. Next, we're going to talk about, yes, we're going to talk about now this compound, again C1 and C2. What's the hybridization of C1? What's the, by the way, what's the electron domain first?
AB2 E0.
AB2 E0, exactly. What's the electron domain for C2?
SP.
Electron domain the same, AB2. And what hybridization we're going to have?
SB.
SP. And this one? Also
The same.
SP. What are you going to mix then? 1s with what?
1B.
1p only. And how many p orbital will be left?
2.
2p. So let's have this one. We're going to make sp and sp like this, and 2p orbital will be left like this. Now, when they interact with each other, this is the carbon. This one is called sp. This one is called sp. And this one, p orbital and p orbital. What will happen to this sp and this hydrogen? We're going to have sigma. All right? This carbon and this hydrogen, also sigma. Between this carbon and this carbon, the green orbital, what type of bond?
Sigma.
Also sigma. But this orbital with this orbital will interact to make what?
Pi.
Pi. And this orbital, which is side, now we cannot do it in the side. Actually, this orbital with this orbital, they are at the side. I'll draw them with only, because I don't want to make line, but I'll make dot line so that they are in the side. Okay, what type of interaction between this p orbital, this p orbital? Another pi bond like this, and it will make the structure like this. Okay, again, let's very quickly now. What's the hybridization of carbon in this molecule?
AB2, AB3 E0.
E0. So what type of hybridization?
SB2.
SB2. Fantastic. Let's concentrate on oxygen. What's the electron domain of oxygen?
AB1 E2.
AB1 E2. What hybridization we're going to have?
SP3 SP2.
SP2. Yes, why? Because it's one with two only. I hope this is clear. Very good. And that's how the mixing will take place for the carbon. And actually, this is for the carbon, and this is for oxygen. Can you see here? Okay. In the carbon, there was 2s with 2p to make 3 empty orbitals like this, and 1 with p. But for the oxygen, we have 6 orbitals. I mean, it's actually 2s, 2p, 2. But the valence of oxygen is 2s, 2p4. And that's how the electrons are distributed in oxygen. Because they're both sp2, then this electron will come only 3 electrons here, and 1 will be left for p. And here we have 5 electrons in here, and this one will make the now this orbital will interact with this orbital to make what type of bond?
Pi.
The pi bond. And this orbital will mix with one of this orbital to make what type of bond is this one?
Sigma.
Sigma. These cannot make any bond. The others will come from hydrogen. There is a hydrogen, I will write small electron from hydrogen, small electron from hydrogen to make the bond, because the molecule shape was, this is the oxygen, this is the hydrogen, and this is the hydrogen. So this sigma bond is happening between this orbital of oxygen with this orbital of carbon to make this sigma bond. So this sigma. And this pi bond is between what? The 2p orbital of oxygen with the 2p orbital of carbon. And this sigma bond is between what? The sp2 orbital of carbon with what?
sp2.
Yes, of hydrogen. And this sigma is between the sp2 orbital of carbon and s of hydrogen. They will interact like this. So if you want to draw it like this, I hope this is also clear. All right. Okay, with this, we finish this part. And I'll stop here. Tomorrow, by the way, tomorrow there will be normal recitation and there will be discussion. There is no quiz this week. And we're going to have normal recitation. And I'm going to take attendance as usual. So tomorrow at 8 o'clock, we're going to meet for section 25. At 9 o'clock for section 26. And at 10 o'clock, we're going to meet for section 26. Is this clear? Any question? Okay, with this, I will finish the lecture.